Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over the fundamental identities. There are a total of 23 fundamental identities, and they can be broken into 5 groups. So as we go over each identity in the respective groups, we're going to be highlighting some important facts, tips, and other things concerning each group of identities. So let's start with the reciprocal identity. Now, what does the word reciprocal mean? So, knowledge of this word is crucial in order to understand the process of generating your reciprocal identities and also generating trig ratios with the reciprocal identities. So to reciprocate just simply means to interchange the numerator and the denominator of a fraction. Okay? Or another word for reciprocal, you can think of it as flip. Okay? Reciprocal or flip identity. Now there are 6 of them. Let's start with sine x. Sine x is the function you get when you reciprocate the cosecant function. Okay? If you reciprocate the cosecant function and you get sine x, that follows that cosecant x is the function you get when you reciprocate sine x. Alright? So sine is a reciprocal of cosecant, cosecant is a reciprocal of sine. Now a common mistake most individuals make is that they think that sine go with secant. That's incorrect. Sine goes with cosecant and cosine goes with secant. Let's go ahead and write that down. So cosine x is what you get when you reciprocate the secant function. Okay, so you have your s going with the c's and then your c's going with the s. This follows that secant is the function you get when you reciprocate your cosine function. Okay? So these are your reciprocal identities. You have 2 more. Tan. Tan is a function you get when you reciprocate the cotangent function. Okay? Now what other reciprocal identity can we generate with this particular one right here? We can also conclude that cotangent is what you get when you reciprocate the tangent function. Okay? So these are your 6 reciprocal identities. Now one thing you want to keep in mind, this is very important, thing to note is the difference between the inverse trig identities and the reciprocal identities. Now, as indicated earlier, cosecant is the reciprocal of sine. So, what if you want to write this using the exponential notation? Cosecant x is the entire sine function raised to the -1 power. And this is not equal to this function right here. Okay? This function that I just wrote on the rightmost side is known as the arcsine. Okay? This is the inverse of sine. Whereas this scenario right here, sine x raised to the -1 is the reciprocal of sine. They mean 2 different things, okay? And this fact applies to all 6 trig functions that we have here. You use this one where you want to generate cosecant, and the inverse sine function basically reverses the effect of the sine function. For example, if you're solving a trig equation and you want to undo sine, you use the inverse or arcsine function, not the reciprocal. Okay, so please keep these 2 different notations in mind. They are not the same. Now the next group of identities, there are just 2 identities in this group. These are known as the quotient identities. Now, what does the word quotient mean? Quotient is just a fancy word for divide, okay? So you have a situation where we are generating trig functions by finding the quotient of two other trig functions. The two quotient identities are tan and cotangent. The tan quotient identity is simply sine x divided by cosine x. And cotangent x, we know that tan and cotangent have a reciprocal relationship as indicated in the first group of identities. So applying that alone to the value of tan, sine over cosine, we can automatically conclude that cotangent x is cosine x divided by sine x, basically the reciprocal of sine x over cosine x. Okay, so these are your two quotient identities. Okay, the next set of identities we're going to be looking at are the cofunction identities. Okay, now this identity is basically based on an interesting relationship between complementary angles. So when you see this word CO, think about the geometric term complementary. So what are complementary angles? Complementary angles are angles that add up to 90 degrees. So if you think about a right triangle, for example, let's sketch one. The non-right angles of a right triangle are what? They are complementary. Okay, so let's say this is 90 degrees right here, and this is x, and this is y. X plus y is going to be equal to 90 degrees. They're basically complementary angles. So this is the main idea of cofunction identities. So x plus y equals pi over 2. And then we can say that x is pi over 2 minus y, or you can say y is pi over 2 minus x. Okay? So when you see co and cofunction, think complementary angles that add up to 90 degrees. Alright, so what are they? Sine and cosine are cofunctions. What does that mean? Sine of pi over 2 minus x. The sine of the complement of an angle is equal to the cosine of that angle. It also follows that the cosine of the complement of an angle is equal to sine of that angle. Okay? Now, how about the cosecant and secant functions? Cosecant and cosecant functions are cofunctions also. So the cosecant of the complement of an angle is equal to the secant of that angle. And the secant of the complement of an angle is equal to the cosecant of that angle. We have two more cofunction identities, tan and cotangent. They are cofunction identities also. So the tan of the complement of an angle is equal to the cotangent of that angle. And the cotangent of the complement of an angle is equal to the tan of that angle. So these are the 6 cofunction identities. Now the next set of fundamental identities that there are called the Pythagorean identities. Okay. Now where do you think the Pythagorean identities originate from? Well, they originate from the Pythagorean theorem. Okay, so let's take a look at that real quick. Now, if you have a right triangle, we know that the Pythagorean theorem is only applicable to right triangles. So let's say we have a right triangle, and this is our angle under consideration, x. Okay, if that's the angle x, this will be the opposite. This will be the hypotenuse, the side opposite the 90-degree angle. and this would be the adjacent. Alrighty. So the relationship between this angle and any pair of sides on this right triangle can be summed up using the terminology SOHCAHTOA. Okay, it relates any of the two non-right angles with a pair of sides of a right triangle. Okay, so let's leave that for a second. Let's think about the Pythagorean theorem. So we have this side, one of the legs is A, this is B, and this is C, right? So what's the Pythagorean theorem? The Pythagorean theorem is A square plus B square equals C square. Okay, so the trig version of the Pythagorean theorem is simply O square plus A square equals H square. Alright, so let's take a look at this for a second. What happens if we divide the entire equation by O square, if we divide the entire equation by A square, and if we divide the entire equation by H square? What's going to happen is that we are going to end up with the three Pythagorean identities. Okay, so let's go ahead and do it. So let's start with the first one. O square plus A square equals H square. So how about we divide by H square? So if we divide by H square, H square, H square, using the quotient property of exponents, this actually the power of a quotient property, the reversal of the power of a quotient property of exponents. This can be written as O over H square plus A over H square plus 1. Okay, because this divides out. Now what is O over H? That's sine. So this is telling us that sine square plus cosine square is equal to 1. Alrighty, so that's one of our Pythagorean identities. Sine square x plus cosine square x is equal to 1. We know that sine in SO is opposite of a hypotenuse, ka. Cosine is adjacent of a hypotenuse, and t for tan is opposite of a adjacent. Alrighty, so that's the first one. Now, what if we have, go back, I'm going to rewrite this, okay? Let's go A square plus O square. We know that addition commutes, the order doesn't really matter, is equal to H square. Now, what happens if we divide everything by, how about we divide everything by A square? Okay, we already did H. If you divide everything by A square, what will result? Now, using the reversal of the power of a quotient property of exponents, we can rewrite this. This becomes just 1 plus O over A square equals H over A square. Okay? Now, in SOHCAHTOA, let me just write this out so it's clear what I am doing. So sine theta is opposite over hypotenuse. That's so. And then cosine theta is adjacent over hypotenuse. That's ka. And then tan theta is opposite over adjacent. So we have over A here. This is going to be tan square. H over A. A over H is cosine, so its reciprocal cosecant is going to be H over A. So this tells me another Pythagorean identity, which is that 1 plus over A squared tan square x is equal to hypotenuse of adjacent square, which is a reciprocal of cosine square, which is secant square x. So that's the second Pythagorean identity. Now we've divided by H square, we've divided by A square. What is left? We divide by O square. Okay, so let's say we have A square plus O square plus H square, the Pythagorean theorem again in trig version, and we divide each and every term by O square. So O square divide this by o square, and divide that by o square. Using the property of exponents, I can rewrite this as a over o square plus, these ones cancel out to just 1, equals h hypotenuse over opposite square. Okay? Now let me rewrite this. I can switch this around. I can write it as 1 plus adjacent over opposite square equals hypotenuse over opposite square. I'm just putting it in the form that's consistent with how you will see it in most textbooks. Okay? So this is going to be 1 plus adjacent over opposite is the reciprocal of opposite over adjacent. Opposite of adjacent is tan, so its reciprocal is cotangent. So cotangent square x is equal to, now what on earth is h over o square? That is the reciprocal of over h, the reciprocal of sine. When you reciprocate sine, you get cosecant. So you have cosecant square x. So these are the 3 Pythagorean identities, and you can clearly see how they came about from the Pythagorean theorem in collaboration with SOHCAHTOA. Now the last set of fundamental identities are your odd and even identities. Okay, odd and even identities. All right, these ones are also known as the negative angle identities, okay, because we're going to be inputting negative sign for the input angles. So before we do this, let's just go over a side point real quick, something you want to remember. So real quick reminder here. Now what happens when you raise a negative number to an odd power? Your result is going to be negative, right? How about if you take a negative number and raise it to an even power? What's your result going to be? If you take a negative number and you raise it to an even power, your answer is going to be positive. Okay, so just something to keep in mind when you input negative for the input values of an odd function, you end up with the opposite of that function. However, when you input a negative for the input of an even function, you end up with the original function. It doesn't have any change on the function at all. Okay, so this pattern will manifest itself in the identities that we're about to look at. Now, let's do the odd ones first. Okay, odd ones, you put a negative, you get negative back out. So, sine of negative x, sine is an odd function. So when you have a negative angle, it becomes negative sine x. Cosecant, its reciprocal exhibits exactly the same behavior. Why is that? Reciprocating a function does not alter the sign, okay? So cosecant is odd also. So we have negative cosecant x. Now there are 2 more odd functions, but I'm going to go to the even functions first because we can see the relationship by examining the behavior of the odd and even functions within the context of the quotient identity. Okay, so cosine is even, which basically means that cosine of negative x is going to return the original function. It's going to be positive, it's not negative. And then secant of negative x is going to be secant x. Now, what does this tell us about tan? Tan is an odd function. Does that surprise you? Well, tan is sine of a cosine, right? So when we divide these two, minus over plus was going to end up, was a sign. Negative over positive is going to be negative. So because of the odd nature of sine and the even nature of the denominator cosine, tan is going to be odd because the negativity remains. So tan is odd. Now, what do you think about tan's reciprocal? What impact does reciprocation have on the sign? It has no impact, so guess what? Cotangent is also an odd function. Okay, so for your odd and even functions, also known as your negative angles function, we have two even functions and the remaining four are odd. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your study of identities, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation, just place it in the comment section below and we'll be more than glad to respond. Do subscribe to our channel because we update our YouTube page with math tutorials on a regular basis. So subscribe so you can get notifications of our latest uploads. More clips can be found on math.gotserved.com. Thanks again for watching and have a wonderful day. Goodbye.